The buffer pool serves as the primary in-memory cache for page data retrieved from persistent storage. All read and write operations on table pages route through the subsystem. The pool maintains a fixed allocation of virtual memory, typically between 2 and 64 gigabytes depending on system configuration. When all available slots contain pinned or dirty pages, new requests enter a queue pending eviction of less frequently accessed data. The buffer descriptor table maintains metadata for each cached page. Each descriptor occupies 64 bytes and stores the following immutable fields: page identifier, containing table identifier, partition number, and creation timestamp. Mutable fields include reference count, dirty bit, pinned bit, and current eviction policy priority value. The reference count increments when a transaction obtains a handle to the page and decrements upon release. The least recently used eviction policy constitutes the default replacement strategy. When eviction becomes necessary, the system scans the descriptor table in insertion order and selects the first page satisfying 3 conditions: reference count equals 0, pinned bit is false, and dirty bit is false. The timestamp of this eviction operation is recorded in the system event log for diagnostic purposes. Dirty page eviction requires an additional write operation to persistent storage before the buffer slot can be reused. The system writes the page content to the write-ahead log location specified in the page descriptor. This write operation completes synchronously. The eviction process does not return until acknowledgement is received from the storage layer. The dirty bit is cleared upon successful log write completion. The pinned bit prevents a page from entering the eviction candidate set. A page becomes pinned when a transaction holds an active cursor over its contents, or when a background process requires the page to remain memory resident. The pinning mechanism implements a counter, permitting multiple concurrent holders. A page is only unpinnable when all pinning references have been released. Page access patterns are recorded through a sliding window histogram maintained in shared memory. The system divides recent history into 10-second intervals, storing the number of read and write operations occurring in each window. This data permits administrators to identify hot pages consuming excessive memory resources. Pages with 0 accesses in the preceding 5 minutes receive an eviction priority boost. Secondary eviction policies include most recently used and clock algorithms. The most recently used mode selects for eviction the page with the most recent access timestamp. The clock algorithm maintains a rotating pointer advancing through the descriptor table at regular intervals. Pages are evicted in encounter order, unless their reference bit is set, in which case the bit is cleared and the pointer advances. Configuration of eviction policy selection occurs at initialization time through the eviction strategy parameter in the configuration file. Valid options are LRU, MRU, and clock. The parameter accepts string values case-insensitively. If an unrecognized value is provided, the system logs a warning and defaults to LRU behavior. Policy changes require complete system restart and cannot be modified during runtime. The pool performs periodic maintenance operations every 30 seconds by default. During maintenance, the system scans for pages that have accumulated excessive versioning overhead and marks them for background compaction. Pages requiring more than 8 kilobytes of undue information are placed into a deferred compaction queue. Actual compaction occurs during low traffic periods or when the queue size exceeds 100 entries. Eviction rate monitoring is exposed through the system metrics interface. The metric evictions per second returns a floating point value indicating the current load on the eviction subsystem. Sustained rates above 1 eviction per second indicate pressure on available buffer slots. The metric eviction wait time measures the median milliseconds spent in the eviction queue by pages awaiting eviction. Both metrics reset every 5 minutes. Adaptive pool sizing adjusts the buffer allocation based on observed access patterns. The system measures the ratio of evictions to total pool accesses every 10 minutes. If eviction ratio exceeds a configurable threshold, typically 8%, and available system memory permits, the pool increases its allocation by 10%. Conversely, sustained low eviction ratios trigger gradual pool contraction. The buffer pool implements a write-ahead logging guarantee for all dirty pages. Before any page becomes eligible for eviction, its contents must be persisted to the write-ahead log. This ordering constraint is enforced through the WAL sequence number field in each descriptor. Pages cannot be evicted until their WAL entry has been flushed and the sequence number confirmed by the log subsystem. Eviction callbacks allow registered background processes to execute code immediately before a page is removed from the buffer. Callbacks receive the page identifier and descriptor as arguments. The callback system enforces a maximum execution time of 50 milliseconds. If a callback exceeds this limit, the system logs an error, cancels the callback, and proceeds with eviction. Callbacks cannot modify the page contents or prevent eviction. Pool statistics are persisted to a fixed-size circular buffer in shared memory. The system records eviction events, including page identifier, eviction policy used, and reason for eviction. This history maintains the last 10,000 events. Older entries are automatically overwritten as new entries arrive. Administrative utilities read this buffer without acquiring locks, using atomic memory reads. Eviction stalls occur when all buffer slots are pinned and no new requests can be satisfied. The system monitors stall duration and emits periodic warning messages if stalls exceed 5 seconds. Long stalls indicate potential deadlock conditions or excessive concurrent transaction load. Applications should implement backpressure mechanisms to reduce concurrent requests when stall warnings are detected. The buffer pool subsystem performs internal consistency checks at every fourth eviction cycle. These checks verify descriptor table integrity and confirm that all buffer addresses are aligned to page boundaries. If inconsistencies are detected, the system enters a degraded state and emits a critical severity log message. Continued operation is permitted, but automatic pool resizing is disabled.